Go to applications, because I know that you will ask about that. With the attosecond physics and science, we have come to the point where we can have localization control of electrons in a molecule. This is a new field that can be called attochemistry, where you can locate electrons in a molecule and you can figure out what they are doing, jumping around. Ultrafast switching from insulator to conductor. This is a dielectric material, for example, silicon dioxide. You can switch with an attosecond pulse between a situation where this dielectric is not conducting, it's an insulator, but in 1 femtosecond, you increase the conductivity by 18 orders of magnitude. And of course, this is an important field because it gives you possibilities to develop very fast electronics based on these short pulses. And the final example, which is now being pursued by Ferenc Krauss now in Garching, is molecular fingerprinting applied to biological samples. So what is this? Well, you have a blood sample. You expose it to a very short infrared pulse. This infrared pulse will vibrationally excite the molecules in the blood sample. And there are literally thousands of molecules in this blood sample. And then they emit infrared, and you detect this. And by analyzing what you detect, you can, and doing this with attosecond precision, you can draw conclusions whether there has been any change in the blood sample. So the idea here is not to analyze all the 1,000 molecules, but to find small, minute changes. And by doing this, there is the hope in the future that you will be able to capture whether a person have developed, for example, lung cancer in the body, so that you have a very sensitive method. And if you can diagnose cancer at a very early stage, treatment will be much more successful. So this was just a few examples, and I'm sure that you have a chance to ask the Nobel laureate afterwards. So I thank you now for my presentation,